In this lesson, we consider two variables, x and y, which are measured on the same individuals. So there are two different measures on the same individuals. For the value, for example, for the value of x equals 1, y is found to be 2. We start with this particular example. For x equals 2, y is 3, and so on. This is a data graphed on a graph of x against y. We want to develop a linear model to predict the value of y when the value of x is given. So in this model, we rely more on x to be calculated or measured, and from it we need to find or to predict the value of y. We are looking only at the linear model, so we are looking at a line to have a best fit for these 3 points, a line that is the closest to the 3 points. Such a line is called the line of best fit, and the method used to find this line is called the method of least squares. Such a line will always pass through the mean point of the data, and the mean point of my data is the x mean is, and the y mean value. So my line will pass through the point M of coordinates 3, 3. And seems to look 3, 3 is a point here. So let's assume the line looks in this way, going to this point. So I'm looking for the equation of a line y equals mx plus c. I know that the point M is on this line, therefore 3 equals 3m plus c. So my equation is in the form y equals mx plus 3 minus 3m. I need to find the gradient of this line, which will make these 3 points the closest to the line. And my method will be that I want the square of this distance, is the distance of the point to the line, to be as small as possible. The sum of the distances to be as small as possible. Now, because I don't want to work with square roots, I will consider the sum of the squares of these distances. As an example, if we take the point of coordinates 6, 4, the distance of this point to the line, the vertical, we'll consider the vertical distances. So the vertical distance, the corresponding point on the line, is for x equals 6, y equals, and if we look at the equation of the line, y equals mx plus 3 minus 3m. The y value will be mx plus 3 minus 3m. Therefore, the square of the distance will be 6m plus 3 minus 3m minus 4 squared. And I will repeat this procedure for all the other points. For the second point of coordinates 2, 3, the corresponding point on the line with the same x coordinate will be 2m plus 3 minus 3m. So the distance square is the difference between the y values of these 2 points that come vertically one on the top of the other. So this is a distance square. I'll calculate the same distance from the third point, and then I will need these 3 distances, the square of these 3 distances, to be as minimum as possible. So we want the sum of the distances to be minimum. This is the sum of the distances for each of the points. And we get this quadratic expression in M, which reaches its minimum for M, giving a derivative equals 0, so for this M. Remember that m was the slope of the line we are looking for. C was 3 minus 3m. So this is a regression line of y on x, used to predict y when x is given. Now, how accurate is that prediction, we'll see later. Of course, if points are closest to the line, the closer the points are to the line, the best is our prediction for future y's. The good news is that we are not going to calculate the line in this way every time. This is just for us to understand where from it comes. And we'll see how our GDC gets the same line of regression just within a few button presses. Turn start plot on. Choose a type of data that you want. X list 1, Y list 2. And here is the data. Okay, let us now find the equation of the regression line. Under option to calc, option number 4. We need to be very careful here. X list is under list L1 and Y values are under list L2. I want to store the equation under the variable Y1 such that I don't write it on the paper and then type it under y equals, because I want at the end to see the line drawn. For comparison, this is the equation of the line I got, and these are the A and B. Gradient and y-intercept of this equation, so practically it is the same. Yeah, well done. Let's see next how we draw this equation, and we see how it comes on the graph. We have it under y equals, see, it's already saved there. Here it is. This line helps whenever a value of x is given to predict what is going to be the value of y for that x. Remember, we took into account just the vertical distances. So that line, that's why it's called the line of regression of y on x when x is given. In the cases when y will be given, we can't use this line to predict x from it. This will not be a good prediction. We are going to use another line, the line of regression on x of x on y. Our next step will be to devise a general formula in the case we have not 3 points by n points. So we are looking for generalization. We take n points, coordinates x1, y1, x2, y2, and so on, xn, yn. And we consider x bar the mean point on the x-axis, the sum of all x values divided by their number, and y bar the mean of the y values. We are looking for a regression line in the form y equals mx plus c. We know that the point of coordinates x bar, y bar is on the line, so y bar must be mx bar plus c, and this gives us opportunity to find c and replace it in the equation. So this is the equation that we need to find with the parameter m. So we need to find m such that the sum of the squares of the vertical distances is minimum. So let's take a general point, x, y, y, y. the vertical distance up to the line, it's what we are looking for. This point is going to have the coordinates xi, and because it is on the line, the y coordinate will be, let us write the equation of the line here. So the y coordinate is going to be mxi plus y bar minus mx bar. So the distance that we are looking for, the square of the distance, is going to be mxi plus y bar minus mx bar, and from this one we need to take away y squared, which can be rewritten as m xi minus x bar minus yi minus y bar all squared. We need the sum of these distances to be the minimum possible, so let's calculate the sum of the distances using the sigma symbol. So the sum of the square of the distances will be sum, I starts from 1 to n, those brackets, I'm going to open the bracket, so sum of m squared you might stop the movie and try by yourself and then check the answer. Now it's time to remember the properties of the sigma symbol. So sum y I minus y bar plus sum let us remember that we started with an expression in m, so this m does not depend on I, so, or I can put it in front here the same, and I end up with a quadratic expression in m, which I'm going to write on the next page. So we end up with a quadratic expression. It's like an a m squared minus b m plus c, and it reaches minimum if you have y equals a m squared plus bm plus c is minimum for dy by dm equals 0, so for m equals minus b over 2a. In my case, it reaches minimum for the distance is minimum for minus b over 2a, so for m being sum So here it is, the formula of the gradient of the regression line of y on x. The formula looks complicated, but now you know where from it comes. And in the vast majority of the cases, you'll be asked to find it using your GDC. We'll see in a further lesson how well we can approximate the value of y when x is given. So your final equation of the regression line is y equals mx plus, with the m the value above, which can be rewritten if you want in a simpler way which maybe it's easier to comprehend.